before we start, I want you to, if you have the FatCat demo, you can get that started, and so you can see what that demo is. We can look at the visualization for that. So just do TCSH, do 00 presto all runs. Yes?
So CD under AFNI, CD to AFNI underscore demos / FatCat demo.
Yeah. AFNI underscore demos, FatCat demo, that's the directory. And then do this, do 00 presto and tab. It goes through a lot of different steps. Not sure if mine's finished yet. Nope, it's not finished. Okay. All right. So while that's running, we can talk about some other things. So I want to describe some of the ways that you can drive AFNI and SUMA. This is a really powerful function of AFNI that you can script a lot of things, even the GUI in AFNI. So we know that we can script regular commands, but we can even call the GUI and have it do things for us, and let's go through some examples. So everything about driving AFNI is described in more detail in the readme.driver document. So that should be in your abin directory. Let's see if I'll just, I think I may have a tab open for it already. So you can drive AFNI with a command and you give it arguments, or you can call AFNI-com and then you give it a command on the command line. So when you start AFNI, you can give it a command and it will do this series of commands. So here we've started AFNI, tell it to open an axial image and then switch the underlay to the anatomical data set and then save that axial image into a JPEG file called ss.jpg and then quit out of AFNI. And then it follows with a regular command just to look at a particular directory. That's kind of the simplest example, but all of the possible functions are described in this. We have how to add colors, set thresholds, set how many panes in your color bar, whether you're looking at positive or negative. So a long list of different commands that you can tell AFNI to do from outside AFNI or on the command line when you call AFNI as it is. So this is useful because you can create lots of scripts to make AFNI do things for you. Either you can take advantage that when you're doing this, AFNI is still interactive as you're doing it. So if you want to look at some other aspect, you can do that, but you can direct have your users, if you write it for somebody else, to always look at the same thing. You can have it for yourself so that you always look at this slice and save some slice as a quality control image. So these kinds of things are very useful and as just for viewing and for quality control tools. Okay, so let's go through that, and we have another readme.environment. I showed you that in the first session, that these are the environment variables. This controls other aspects of AFNI. And here's another long list of things that control what AFNI uses. Things like AFNI orient, what coordinate order should AFNI use by default, what gets shown there, where do you keep your plugins, what directory those are in, whether hints are turned on as you hover over a button. So lots of different choices there too. Let's look at an example of a way to call AFNI, and one of those that comes with the AFNI binaries is called @drive_AFNI. So in a terminal window, you can go ahead and do that by switching to your home directory. It will look to see what it's actually doing, but just so you can use it, let me open up a new terminal window. And in your home directory, you can call @drive_AFNI somewhere just above your AFNI data 6 directory, because it's going to look at the AFNI data 6 AFNI directory that we've been looking at all week, and it will run these series of commands. So before I start it, let's take a look and see what it's doing. So the script starts out with some help, and then it has a tag so that it can talk to AFNI with a specific instance of communication. So it knows that this is a drive AFNI demo. That's just, it's not necessary, but if you have multiple AFNI and plug-out drives talking to each other, they will know about which one, you'll know which one is which. Okay, so some details here. So this starts AFNI with these important options for -niml and yes plugouts. And the -niml tells it that it could communicate with something like SUMA or some other program that can talk in the NIMH markup language over TCP/IP with the AFNI. And the -yes plugout says that we can use plugout drive, and this is what we're going to use here, and then what directory to look at. Okay, and we're going to redirect all the output to /dev null, so we don't even see anything that AFNI will report here. Okay, so then we call this program plugout drive. So this is a convenient way to send things to AFNI. Plugout drive, you give it the command just as you would on the command line of AFNI. So you put AFNI-com, all these different things, or you can do plugout drive -com and then the commands there. So here, we tell it to switch to the A session of AFNI and open an axial image. That window should be this large and have these properties. And there are other properties, of course. Axial image, open a sagittal image, switch the underlay to the anatomical data set, and switch the overlay to the skull strip data set. And then turn the overlay on. And then simulate pressing the V key. So here we can simulate key presses by scripting. So this is really handy. So this will turn on that video mode. So we're going to go through all the slices with that V key. All right, and then we're going to prompt the user that to whether we should go on or not. So we have a command prompt user, and that will stop it for a moment. And it goes through. It says open another window. Put the space bar to stop the video. Now set up a montage for me. That's 6x3, 8 slices apart, and then go to a specific coordinate in DICOM RAI order. And then save a picture of that montaged axial, those axial slices. Okay, it goes on. We can turn on we can go through a graph window and press the V key. We can turn on the overlay here, look at the func_slim data set that we've been looking at, set the threshold to a p-value of 0.001, and set the range of the overlay, and go to another coordinate. And then at the end, we can tell AFNI to quit. So, simple program. Use this as a kind of a template for your own plugout drive scripts. And I think you'll find it very handy. So let's just try that. From the home directory or somewhere over your AFNI data 6 directory, let's just hit @drive AFNI. Okay, it's echoing out our plugout drive command. Okay, so we've got the overlay on. It's pressed the video key for us, and it's prompted us to go on to the next step. Okay, so AFNI is live while we're doing this. We can still do other things in AFNI. Even though it's being scripted, we can do other things. It's still available to us. Okay, now it's set the montage for us, and the montage is still available. We can move through the image. We can select OK. And it's now saved the axial image for us, and it's opened it up for us to see with AIV, the AIV program. So we can see our montage as a separate image. So these kinds of things are really useful for quality control. You want to see all your slices. You want to see overlays, underlays. It's an automated way to do all this. Okay, now it's going to go through and it's put the EPI data set here as our underlay, and it's put simulated pressing the V key over the graph window. So we can use that to look for motion. So if you have a new student, postdoc, somebody who isn't familiar with fMRI and you want them to see how to look at things, you can make a script for them to do this. Okay, so this can be a kind of teaching tool as well. Okay, so hit OK to pause the movie. And now it's changed the overlay to the contrast between the reliable visual and auditory stimulus for the coefficient, and the T-stat is the threshold. So it's thresholded that's for us, and it's jumped to a particular coordinate. And that's it for the @drive AFNI script. Were there any questions about that and about any kinds of its capabilities?
Yeah, I tried doing that for my own data, but then I tried to make by the script, and I tried changing this to NIMH to the problem of my data, but then
Okay. Yeah, it's usually not too difficult. If you have multiple copies of AFNI running at the same time, it can be a little bit confusing because then you need to set up separate port blocks for each one, but there's a kind of automated way to do that. But it could just be some small syntax issue. The one thing that you should know about in plug-out drive is you can open plug-out drive all by itself, and then it becomes a kind of interactive prompt. You can just try different commands, and AFNI will tell you whether they're okay or not. Yeah, you should turn off the dev null business so you can actually see what comes out of it, what comes out of AFNI, because if there's an error, it won't say it otherwise. So.
we do this then to go, so I have 45 subjects, and we do this then for every subject, or we can run it and then have it not look at it, but only save the JPEGs and look at the JPEGs.
Yeah, so you can do both, right? I mean, it depends how much time you want to dedicate to it. We have procedures for doing both these kinds of things. I'll show you another thing that we use for kind of looking at lots of different subjects in maybe a little bit faster way. So it depends how much data you've got to look through, whether you've got 10 subjects, 20, 100, 1,000, 10,000, you know, it's more or less detail. So we've got different tools for different jobs. Okay. Uh-huh.
What you were editing for @drive out, we ran it above the control part data. Can you specify full drive out needs for different doing different things, different data sets? Like, oh, I want a rat data set drive out. This.
Yeah, so this is just an example script. So @drive AFNI is just an example. Plug out drive is going to be the tool that you're going to use inside your own script. So this is just made for the class data as an example. So if you have marmosets or macaques or humans of different studies, you're going to have different kinds of scripts most likely for each of those data sets.
Sorry, so that means that the add drive has our reserved scripting.
No, that's
There are the agents, so.
yeah, we provide them as an example, but they're really made to go with our class data. The story of the it's an old story. The @ symbol comes from an old way to run a command language script on old VAX systems. VAX VMS, I believe, had the DCL language, which you would run with an @ symbol. You would say this script. And somehow it got transitioned into our script names. So a kind of code for us to say that these are script names. This is a T-shell script usually, and it's not Python and it's not C compiled C code. So, but it is just an example. It is one of the more unusual things in our distribution, that it's really made for specific data. Probably shouldn't be there. It should probably go with the data, I think. But it's such a good example that most people will need to see it. So, okay. So good question. Thank you. So let's go on. So this is quitting out of AFNI. It doesn't quit out of AIV, so that's still up there. So we'll just close that manually. We have a similar script called. Okay, so we can do AFNI-com. We got a plug out drive. We have the AFNI environment variables. We have a similar script called @drive SUMA, which calls a program called drive SUMA. And drive SUMA is very similar in that similar to plug out drive, it tells SUMA what to do. So we have a script here. We can try it. I found it was a little bit buggy yesterday, and so I fixed my version, I think. But you don't have the version that I fixed. So on my system, I found I had to put in extra time delays. Not sure why in this case, but it seems to work with those time delays. So I'm going to do another script called @drive SUMA. We may want to look at that first. So @drive SUMA, also in our distribution. Let's just scroll down to the more interesting aspects of this. It says make sure that you don't have any other SUMAs running. I don't think I do. And it's going to create an icosahedron and then do some stuff with it in SUMA. Okay, so drive SUMA, show a surface, input it here, create ico.asc. And I think if you look at drive SUMA -help, it gives you some help. But mostly, I would say use these kinds of things as examples, the scripts that we give you, because it's a little tricky to figure out all the contexts of these things. All right, so drive SUMA is fairly long help, but so there's that there. So let's try @drive SUMA. Not sure if it will work on your system, but let's see. Okay, it prompts us to make sure no current SUMA is running and press OK. Okay, it shows us some shape. And it tells us it's going to be doing some other stuff and that we should look at this prompt. And that SUMA is still running, so we can do stuff just as we could in AFNI while it's doing this driving business. Okay, so I'll just select OK to continue. Okay, this is loaded our icosahedron, our simple one. It's a little difficult to see because it's zoomed in so much. But here's a simple icosahedron. It's going to be reprojecting all the nodes onto a sphere. So here our nodes are moved out. And then another coordinate assignment for those nodes. So it looks very different. Still the same topology. And now it's going to control the viewer. It's going to record the movie for us with the control right and press the control right key. Okay, and we'll jump to a location as if we press the control J key. So here you can simulate pressing keystrokes. So that's in this @drive SUMA script. And then it will press the up key 3 times, sleep for 0.3 seconds between presses, and then press the left key twice, and so on, and this is going to be kept in our movie. Okay, and it pauses it there, so let's pause. And now it's turned on momentum. And this is just a remapped icosahedron. It's just a toy example. It's nothing to do with brains, really, so it's just for fun. And mostly just as a lesson for how to drive SUMA.
So Daniel, all of these drives start
Yeah, so it actually, this is the bug I found out last night about this, is it's not just sitting there, it looks like it's just sitting there. The prompt has happened, but for some reason, the window is a single line. Yes, this took me a long time to figure out because this had been working several months ago, and I just assumed that it would work, but something has changed on the X system. So the solution was to put in a sleep of 3 seconds, and I think, let's see if I can show you that. Yeah, I wasn't sure if it was true for everyone. I did update the Git repository because I figured an extra 3 seconds sleep for this demo can't really hurt. So if you edit your file, as I did, you can replace all your set L's with sleep 3 semicolon set L, and then that would insert a 3 second sleep before each prompt. I don't know if you want to go through that, but it's that was my solution. That you replace all the lines that say, there are many lines that say set L equal. So all the sleeps had to be replaced, all the prompts had to be replaced with sleep 3.
You're running at drive SUMA.
I'm running at drive SUMA.
It seemed like it started really for quite a while already.
It's just that the window has reduced to a pretty much invisible function, of invisible size. Sorry about that, but with a little bit extra sleep, at drive SUMA will work, just like all of us. Anyway, so that was my solution late last night, trying to figure out why this wasn't working. Surprised to see that it had stopped.
Yeah, it's not up for all.
Yeah, it depends. If your editor is handy at do a replace all, that could work. Okay, I'm going to continue through the demo. It's changed it from fill mode to points mode, and then you can press enter back to its filled mesh mode. Okay, so here, this recorder can be manipulated like an AFNI viewer. So here, I don't know if we went through this, but in the recorder, there's a recording, and so you can go through the video there. V works in that too. All right, so the @drive SUMA will save your images into a GIF file and save a JPEG file and so on. So it's saving different things. You can tell all the text going through in the terminal back here. And now it's going to load some data. Okay, it's going to load a new surface called Cubo. Okay. That's here. And open the surface controller for it. And it will select which sub-brick, which column of its NIMH data set, its 1D data set, to show as intensity, and change the threshold to. These are all just toy examples, but for your own data, you'll want to do something like this too. And setting the intensity range to 0.05 for this data. It's all green there. So here it looks a little bit more interesting. Now switch to another intensity subbrick and change the range there and threshold to a different level. Now it's changing the brightness. And now it's going to show us convexity back in the kind of default. And change the color. A lot of examples here. These are all examples of how to change color scales. It's mostly here as an example. All the lines there are something that you might want to do, so it goes on through a lot of different variations. And finally changes the color map. And that's it for the Drive SUMA demo. And then that closes that. Any questions about driving SUMA?
Where do we find that script here?
I have updated it in the source code, so it will be in the distribution soon. Just get the next version of AFNI. We'll have it in there. Yeah. Yeah, I remember there's one other sleep that has to happen. There's a prompt within. Oh, when it prompts SUMA to prompt, rather than a prompt outside, there's a prompt inside SUMA. So that prompt has to have a sleep too, because that opens up a window in a similar way, and there's something that X11 doesn't like anymore. So replaced. This is tricky at what, 2 in the morning. So, let's see. Drive SUMA, drive AFNI, drive SUMA. We have @do examples. This is kind of a fun one here. @do examples. This shows you how to use displayable objects in SUMA. Okay, it's another drive SUMA thing. You can edit it as gonna. I don't know. Actually, I didn't try it last night. I was going to try it, and then I got distracted by this thing, the other one. Well, we'll see. I may have to fix this one too. Well, SUMA is, oh, okay, so.
SUMA, now I ran the script, it would run, and then I closed the script, and I opened SUMA, and I have that example.
Yeah, okay, so when SUMA starts without any input, you can hit the comma and period keys and cycle among the different example images, example surfaces. So a lot of examples are in there. Your SUMA's not starting with this? Because I didn't edit @do examples last night, so should. You do comma and period, so you can start SUMA any place, and it's got these kind of built-in surfaces. Okay, and in the terminal that it opens up, you can, I think you can just No, it's got a problem. No, okay, so here, I think, it's got the same issue. So, well, that's annoying, so we'll skip that. Yeah, if you look, there's a hidden prompt in there.
Yeah, I get that.
Here.
You get that prompt?
Yeah.
Okay.
Yeah. And then it's.
Okay. I don't know. It's. Well, just to show you what it could potentially do, you can just watch the screen. I can go through this. So it can show you these kinds of objects. Again, I've got and
So, you know, if you want to play with these later stages.
okay. So yeah, I can go through. I have some other examples, and
Okay, so I tried opening SUMA first, and then in a different, and then I ran the scripts. Now I'm getting dialog pop-ups. So I opened SUMA first, and then just in a different terminal window started the scripts, and so with SUMA open, now it seems to be working.
okay. Okay, so it's adding vectors and spheres. So these kinds of things, you can add different shapes for images. You can add planes. And different surfaces, filling modes. And now we're going to show some NIMH displayable objects. So texture images can be added in. So we can add in a picture into the scene. What is the story of AFNI, man? I don't really know.
Like having websites where you design the whole screen.
Ah, yeah,
That's what brought me to this minute comic platforms.
that's right. Yeah. So here we have, you can color your images with color your surface, your displayable objects with an image too. Some text. You can have it do the keystrokes and zoom in. And I can see I have a window there. So, okay. And that's it for the displayable objects. So some extra kinds of things that you can put into a scene with surfaces. Another thing we have is called @chauffeur AFNI. This has been a fairly popular program, so you can make montages automatically, and it's a short script itself. So @chauffeur AFNI. This is a general utility, and mostly it brings in a lot of different options, and most of its work is done right near the bottom of this. It's pretty far down, I think. Oh, I missed it. Okay. The actual driven command is AFNI-no plugin. So this doesn't use plugout drive. It actually calls AFNI with the -com option. And beforehand, well, it's running XP. I think I'm at the wrong one. So let's see. Let's find my XVFB. Okay, so here it's going to do XVFB. And the XVFB part is so that you don't actually see AFNI running. It's just setting it up with a virtual X11 virtual frame buffer. So AFNI starts, it does its business, it saves images. We've asked for it to do, but you'll never see it. This is handy if you're running AFNI on a server remotely, and you don't actually need to see the process of saving the JPEG images, the montages. You're creating a quality control report that you're going to look at all these montages later. So let's run this program, and I have an example here. You can just watch this. So you can give it lots of different options. What's the underlay? What's the overlay? What's the color bar? And so on. So and the size of the montage you want to look at. These are you could do this all yourself with the plug-out drive. This is just a little bit easier. You can have it. It does the X-frame, the XVFB business, so you don't have to see it. And so this has been a pretty popular tool. So let's, I'm going to just copy this. And I'm going to run this in my AFNI Data 6 AFNI directory. And so there's my name there. Okay, so it created the montages and wrote it out, and we didn't actually see AFNI pop up. Okay, so now we can look at the output with some sort of graphics viewer like AIV, or our AFNI image viewer. You could use Eye of Gnome or something else too. And this is what @chauffeur AFNI has done for us. It's created these montages with the overlay and underlay selected and thresholded for us, and it does it for. Let's go through the slider at the bottom. We have the axial and the coronal and the sagittal. So it's a handy little tool. It's yet another way to just drive AFNI to do stuff for you. I just, you can make, they're fairly short commands, but I used it in I have just a text file that is not in distribution for the class. It's just a kind of last minute addition here. So I can make this available too. It's a very simple program. It's setting our color scale to that particular color scale too. There's a similar program @Adjunct 4D Imager. So that one shows us similar kinds of things as @Chauffeur AFNI, but it's showing us montages across time and across space. So if you want to see particular slices at different time points, it'll give us a montage of those things, which is a little bit tricky to do otherwise. So this will be a convenient tool for that. Rick has already shown you the @SSReview Basic and the @SS Review Driver. These are two other kinds of scripts to drive AFNI and give you quality control information. We also have the @Snapshot Volreg. So if I do that in this directory and I give it just an EPI data set, two data sets that I want to see if they're in register with each other, whether they're aligned, I can do that here. I'll paste that @Snapshot Volreg. It calls the XVFB, the virtual frame buffer. It's going to put some edges on our images and then open up AFNI and save it for us as a picture.
Maybe we could dump a text file like this and have it help us like drive examples like this or something.
Yeah.
So this would need to be in full data sets.
Yeah. So, or I mean, you can call it on the command line with the data set where the paths are. It will save it locally though. Okay, so it saves our data set as our test snapshot. So let's just look at that again with AIV. And that's what it's done for us. It's shown us the edges of the API with the anatomical data set. So another way, it's just a way that you can check to see if your data is aligned quickly just at a glance. All right, we have the @add edge script. This one does something similar. It's called by align EPI and add if you want, but it can also be called on the command line by itself. You can do something similar as @snapshot valreg. It will drive AFNI in the second usage. It will drive AFNI to show either with a single edge or a double edge, and show you the two data sets over each other. You can have 5 different things, 5 different data sets, 5 different ways to see the same data set. So we use the @add edge script for evaluating our LPC technique and comparing it with other methods. And so we could do that here.